Okay, so this equation here, this question really should say the roots of the equation, negative 2 tan theta plus 5 is equal to 7, is, and then we have the list of options there. So we're going to go through and we're going to solve this. So negative 2 tan theta, first of all, we're going to bring the 5 over. So we're going to subtract 5 from both sides, and that'll get us 2. Then I'm going to divide both sides of the equation by negative 2, and that'll get me negative 1. So tangent is equal to negative 1. Now, tangent is going to be positive in whatever quadrant both x and y are positive. It will be negative in any quadrant where one of those two is positive and the other one's negative. So what we're talking about here are angles here that are going to be in the second or fourth quadrants. Okay, now the reference angle, and I usually use alpha to represent the reference angle. There's lots of different variations. It doesn't really matter, just as long as you know what I'm talking about. The reference angle is going to be that little angle, that little acute angle that exists between the terminal arm and the x-axis. Now in this case, we know, or at least that's one of the things that we kind of want you to remember, that tangent is linked to the number 1 through a reference angle of pi over 4. Okay, the tangent of pi over 4 is going to equal 1. So now we're going to put that reference angle in the two quadrants where tangent is negative. And remember what we're doing here, you can see by the reference angle, what we're doing is we're dividing the top half of the circle into quarters. And so this angle right here is going to be 3 pi over 4. So starting at 3 pi over 4, so here we go, I can get the next angle down here by simply adding pi to it. And in fact, every time I then add pi beyond that, I keep cycling between those two terminal arms and those two sets of angles here. So what I need is 3 pi over 4 plus multiples of pi. And we can see right there, that is answer C.